Hello, I'm Joshua Kahr. Today I'd like to show you a little bit of math that I've used when building financial models for condominium deals. This ratio that I want to show you does not have an official name, but it's incredibly useful. Over the last 15 years of teaching, I've kidded around repeatedly, and I admit it's something of a weak joke that someday I'd start a petition to name the ratio I'm about to show you after myself. Sadly, I've been unsuccessful up until this point, so I guess this is my first official attempt to try to move this process forward. Regardless of my ego-driven flight of fancy, I want to show you some math. I think you'll find it really interesting, and it'll be a good conversation. So off we go. So first off, let's take something really simple. We have here a schedule of what a lender is giving us. That's the draws. That's in column B. And we have sales, and that's in column C. If we take the draws and we take the sales, we've got $3.9 million from the lender and $7.5 million in sales. That's a ratio of around 1.2. So basically what this is saying is we're selling roughly twice as much product as we owe the bank. Of course, this is saying nothing about interest rates. This is not taking into account time value of money. It's just simply saying the bank gives us X, we sell 1.92X. Okay, so how do we factor interest rates and time value of money into it? This is where it gets interesting. Let's take the same draws and the same sales, and let's discount the draws at the interest rate and the sales at the interest rate. And in each of these cells in column O and column P, we have a PV function. You can see it's taking the interest rate divided by 12. It's got the month we're in, 0 intermediate payments, the future draw, it PVs it. So we got the PV of the draws, the PV of the sales. If we add up all the draws, it's 3.8 million. If we add up all the sales, it's 6.8. If I divide the 3.8 by the 6.8, we get 56%. What that 56% is saying, in plain English, is for every dollar of product we sell, we need to pay back 56.5% of every dollar in the given month that we're selling the product in order to get whole. It's sort of a break-even calculation, if you will, but it's a break-even calculation for not what do we need to break even to like pay back our equity, but rather what do we need to break even in order to pay back our debt. I find this ratio to be useful, and I've seen it used in a number of ways. The most common way I've seen it used is in distress situations. It basically tells you how much you can discount your product by and still be able to pay off the loan. It's also useful if you realize that it'll take you longer than expected to sell off the product, or you're trying to quantify whether or not a slower than expected sales schedule will result in you not being able to pay off the loan at all. Basically, like I said, it's a break-even calculation, but not to see whether or not you're profitable, just simply to see whether or not you're going to be able to pay off the lender. Now, how do I know that this 56% is actually the value? How do I know that that 56% of the sales will work? Well, let me prove it to you. If I scroll down a little, we have the draws, the interest, the total draws, payment, and ending balance. This is a basic construction loan schedule where we're paying off the loan balance, and slowly but surely, as you can see, as the draws go up, the balance goes up, and as the payments kick in, the balance starts to go down. This is a pretty, again, typical construction draw schedule. You can see the draws and the total draw and the interest, that's the difference, and well, that's all kind of normal and good. Now let's take this ratio as 56%, and let's take what we're selling, and I'm going to prove that 56% of that sales that we have coming in is exactly what we need to pay off the loan balance. If we take that 56%, which again for humor value I'm calling the Kahr ratio, I don't know the name for this percentage, so that's what I'm calling it today. If I take the sales and I multiply it by my ratio, I get a series of values. If I take that series of values, 79, 175, 305, 248, 231, 79. If I take that series of values and I put it into the same construction loan schedule, that series of values, that payment schedule, is going to be the exact amount of payments I need to receive in order to get the ending balance to zero. So again, the way we calculated this was we took the present value of the draws and the sales, we discounted the draws and the sales by the interest rate. When we add those two numbers up and we divide the draws by the sales, we get a ratio, and that ratio tells us for every dollar of product we sell, what percentage do we need to give back in order to pay off the loan in full. That's it. And unless anyone has a better idea, I'm going to name the ratio after myself because I've never seen a good name for this thing. With that little bit of silliness aside, if you're interested in this sort of stuff, you can always check out my website at kahrrealestate.com. That's Kahr realestate.com. Or email me at josh@kahrrealestate.com. Thanks again. Oh yeah, and I forgot to say, I also do Excel modeling classes every few weeks. If you're interested in that, again, please check out my website. And thanks again. Cool. Keep building better models.